All right. We're going to be talking about the JSON RPC, but before we talk about the JSON RPC spec, I wanted to show like this is a work in progress, very work in progress, like unfinished. But hope maybe this I built this with the hopes that this visualizer can help, kind of,
We need a lot of zoom, Josep.
Well,
a lot of zoom.
Like that. Anyways, I built this like with the hopes that we can understand better how this try thing works and whatnot. So we're going to do this. We're going to go to the public console because it's awesome. We're going to connect. If it 1 second. Cool. Now let's go to IBP because the internet connection here is not great. All right, and then great. And we are going to do what? For instance, let's get my system account and we're going to get, this is the storage key of my system account. You've already seen like how this storage key work. I'm going to put the storage key here, okay? And I'm going to ask it to load like the try, like the proof for the value of this storage key, okay? So let's go pick a block, for instance, this one, which happens to be finalized just now. And notice that there is this, in the header, we have this state root hash, right? So the state root hash is, remember what Sean explained before, which is like the Merkle tree, like at the very top, there is a try node at the very top, and the hash of that try node is the state root hash, okay? So if my try visualizer works correctly, which hopefully it will, when I ask it to load the try for this block hash, okay, it looks really bad, but like here we can see like all the proofs. I will explain them in a moment. It looks really bad because I'm still working on it. But the value of this of this node, so this is the root node, and this is the hash of the value of the root node. I have decoded in here. So it should match with the state root. So the state root of that is 7AB0, so it does match. So good, yeah.
We will need even more zoom. It's still not visible.
You're at the end. You can come closer.
I am,
you know, like you can go to there. Yeah.
But
okay.
I am helping the fellas in my row, you know. So
the zoom makes it even worse because
yeah, I'm afraid
I have no work in the CSS, and the zoom makes it worse.
But I'm afraid
doing it on purpose.
That's a skill issue, not a viewing issue.
Be human. No, just kidding. I love him a lot sometimes. Okay, no, now seriously. The storage key here we have the storage key, which is very long, as we saw before. So notice that here this is the state root hash, and it's telling us, hey, I have all these nibbles, but I have this one loaded, which is 2. And then if we go to 2, then, oh, there is 6, doesn't have a partial key. Now we have here I put the accumulated key. So here is 2, 6. This one has a partial key. Remember, it's a try node. Like some of them have partial keys, some of them are compressed. So now we can see how the key gets, longer and longer. And if we go down, we will see that there is this live with hash. So this value should be the hash of the value of my account, actually. So let's see if it is. Because so here, this is decoded. If I click here, I have the encoded version. And if I go to the console, these other stuff, but I'm going to make zoom in a second. I'm going to comment everything. And I'm going to very quickly, is this big enough?
I don't think so.
All right. Who said no?
Who do you think
Who said no?
Who
No,
said?
for real. It's participation points. You'll see. Anyways, no, just kidding. It's fine. So this is the value. I'm going to hash it. From X, because I need this is accessible, I need to pass it as a uint data array, and then I'm going to do in this case is Blake 256 of these, and then I'm going to do 2x so that it's easier to read. And I'm going to do console log. From 2x. Okay, shitty. Awesome. So if I run, no, this is index. This is a spoiler of the stuff that we'll be doing later. What? So the hash value is 4963b, blah, 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 blah. So this hash is 4963, blah, 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 blah. So you can see, like at the leaf, we have this leaf that it doesn't contain the value, because many times when we want to prove something, we don't want to send the value, you just want to send like the proof without the whole value, because sometimes the value is very heavy, and the trie nodes are a lot lighter. And like in this tool, you can also go like, oh, we can see that in the trie above mine, there's another lucky guy that has the same address as mine, but instead of ending with a 4, it ends with an instead of ending with E, it ends with 4. So if I load it, here there is leaf with hash, blah, blah. So if I put this key into the Puppy console, this will load someone else's address. And if I query it, we'll see that there is someone that has just like the existential deposit, it seems. But interestingly, and if we did the same, we'll get it. But like you get the point, right? Like there's this trie, and now from the trie above where my address sits, there happens to be another one, and yeah, like hopefully this thing helps to kind of visualize how things get computed all the way to the top. Does that help a little bit? Like there are all these branches. Some of them have partial keys. The keys get accumulated, and then so on and so forth. Does that make sense? Yeah, hopefully. Okay. I just wanted to show my poor CSS skills. Okay, now we can proceed with JSON RPC. Coolio. Cool. All right. Where is it? Okay. Or is there a way to make this disappear? Okay. What you learn in this session? You'll learn what JSON RPC v2 is, its stateless design, some conventions to make it stateful even if it's stateless. We are going to be discussing different kinds of nodes and whether it's necessary for a node to expose a JSON RPC API. We're going to talk about like the quote-unquote legacy Polkadot JSON RPC API with hands-on examples so that you understand the problems that we have. And then from there, we are going to explain like the modern and why we needed like a proper JSON RPC spec and the goals and an overview with some examples. That's what we're going to be working on today. Super exciting stuff. Okay, so who's familiar with JSON RPC already? Who knows a bit? Cool. All right, so JSON RPC is like this protocol. It's supposed to be, well, it's supposed to, JSON RPC in itself is stateless. It's transport agnostic. It could be working over a WebSocket. It could be working actually because it's stateless. It could be working on against an HTTP server. It could be working, I don't know, in a, inter-process, event, whatever, as long as over TCP directly, like as long as the order of the messages is guaranteed to be arriving in the same order as they are sent, any protocol will do. It's lightweight. It's lightweight remote procedural call. Okay, it defines, like, the protocol is that simple on purpose so that we can put more conventions on top if we want to. So it defines some basic data structures and the rules around the processing. It's basically transfer agnostic, as I said before. Okay, so the first thing is like the request object, right? Like it's RPC, means request, reply. So you normally start by requesting something, and if you're lucky, you're going to get a reply. Yeah? Well, so let's see how this request object is, right? It's super simple. The thing that it must have for it to be a request is an ID. And why do we need an ID? To identify the response, right? We need an ID so that when we get the response, we know that it's the response of that thing that we asked before. Yeah. It must have a method. Why does it have a method? Well, so that the receiver knows what to do, right? It may have params, right? Like there is a property method, always has to be reported. ID always have to be reported. Params, well, if you want to leave it empty, it's up to you. Perhaps like the request doesn't need arguments, right? By the way, the arguments can be both an object and a tuple. But yeah. Then we have the notification object. The notification object is exactly the same as the request object, but without the ID. By the way, something I didn't put here, but it's important, is that the ID could be a string, a number, null, either it's discouraged, but it can be null, and that's it. But like pretty much like for some reason, like so if you're implementing, if any of you one day is implementing a reverse proxy to proxy a JSON RPC server that's behind, please take into account that the strings are valid ID properties, because some implementations they are not spec compliant and they only and they think that the ID must be a number, which is not true. Anyways, the notification object. The notification object, it's exactly like the request object, but without an ID. So if it doesn't have an ID, how do we know to what that relates to, right? It's like a notification object is like it doesn't have an ID. So, well, the point is this. The point is that you're sending a notification, right? And you're sending a notification that it's not a reply to a request. Yeah, we will see how this can be useful later for creating stateful conventions. But like sometimes you can get a notification, which is like a message that doesn't have an ID, and it's basically something that it's not at least not a direct reply to something that you sent, and you cannot likewise. Okay, response. It must have an ID, as we said before. It must have either a result or an error. Like if result is like things went well, error can go well. And if it has an error, it has to have the following properties: a code with some rules, a message, and data. Well, moving on. If you want to see the spec, it's very interesting. It's very simple. It's here. There are other things like batching calls and stuff like that. It's very interesting. Moving on like Donkey Kong. It's not that exciting, and I see that you're falling asleep. So, okay. For stateful connections and subscriptions. So what? Because we said it's stateless, right? What if we want to use JSON RPC for stateful connections to establish subscriptions? Then we must have some sort of convention on top of what we saw before, right? But the way that we can do that is like, okay, the client can act both as a client as a server, can send notifications, right? The server can act like a client, so, and then we can use opaque IDs in these notifications that are only relevant in the context of this stateful connection, and it must be related to some sort of reply that I sent before for a request. Like, hey, I want to subscribe to this. And then, okay, this is your subscription ID, right? Like, I want to like you send some sort of message like, I'm interested in receiving like the chain head subscriptions for the blockchain, for instance, right? And then we get a reply. It's like, okay, this is your opaque ID. I'm going to be sending notifications to you. That object that we saw before that doesn't have an ID. I'm going to be sending notifications to this. And then inside the params of that notification, there is going to be some sort of convention so that we can follow it. Okay, that's the trick to create conventions for stateful conventions for stateful connections. Okay, let's go to the part that is more juicy. Like what? There's a question.
Sorry if this is a dumb question, but it sounds like with the stateful, the last slide, is it a peer-to-peer kind of system, or is it there's no hierarchy? It's like they both are the same level of actors. They can communicate back and forth. Is that kind of what you're saying?
Yeah. So what I was trying to explain is that that's why it's only in the context of their connection. So like stateful, like by stateful, it implies that there is a long living connection that stays open, right? This connection, if we're talking about, it doesn't have to be a network connection, by the way. It can be, for instance, when we talk with a light client, and the light client is in a different process inside the same computer, and we use RPC. But like one of the properties that this connection must have is that the ordering of the messages must be guaranteed. In other words, like if we are talking about a network connection, it has to be over some sort of something that is built on top of TCP, like WebSocket, right? Like when in a WebSocket connection, like the server sends messages in a certain order, and that order is guaranteed. Like it's guaranteed at the application layer. Or we all know that there are shenanigans happening so that we get them in order. Yeah. Does that make sense?
Yeah, I think it does. Yeah, thank you.
So if we have, so like the point here is that JSON RPC was not really designed for this. JSON RPC was designed for request reply. It was not designed for having long-living stateful connections, right? So it was not designed for long-living stateful connections. Yeah, it was designed for like there is a server and there is a client, and then this client asks questions and sometimes sends some notification, like and then the server replies, and that's yeah. But then if you can guarantee a stateful connection with where the order of the messages is guaranteed, then you can. This is a convention on top of it, right? Like this is not JSON RPC. This is a convention that we have created on top of JSON RPC. Like not only we, there are other people that have used this convention when they need subscriptions. Does that make sense? So I just wanted for everyone to understand that JSON RPC in itself is stateless, but we do things on top to create conventions to make it stateful. Does that make sense? And you will see very clearly how that works. It's a bit hacky, but it does the job. There's another question. Sure. But this is the boring part. Like there shouldn't be so many questions here. Okay, next. Sorry. Well, I don't know. The null ID, I don't know. Like it's like probably who did the spec, it's a brain part. Like I don't know. Like in the spec they explain it. Like it's allowed, but it's discouraged. Like I don't know. Like, it's just in the spec. You just need to. I didn't write it. Like yeah. So do nodes have to expose JSON RPC APIs? This is a question for you, actually. Let's think about it, right? Like. Is it required for like a full node to expose the JSON RPC? What do you think? And if like, or let me ask it differently, why would a full node expose a JSON RPC API? Microphones?
For example, for telemetry. right? If you want to ask like what was last block, what was last action, you could ask the
So
node
for debugging
directly.
purposes,
Mostly for information, for statistics,
information to who?
to users. For example, they want to run a telemetry, they want to run statistics,
any
they want
user?
logs or something, see logs.
But like, do you think like normally people put like full nodes? Like you think that the same? You think that the JSON RPC API of a full node should be fully available to everyone, just like the peer-to-peer connections that they expose? That's my point. And do you see any problem with doing that?
I think it can be, but I don't know if it must. That's my answer.
And if yeah, if someone else wants to give their opinion.
Okay, so we can send transactions. RPC call.
Actually, no, because the transactions get broadcasted through the peer-to-peer protocol. So like, this is a good point. It's a good point. Like you need to, like, this is a good point. Like when I send a transaction to Smoldot, right? Like it just so happens that with Smoldot, I talk through JSON RPC, but I could talk with another way. But when Smoldot, the light client broadcasts a transaction, it doesn't do it through JSON RPC. It does it through the peer-to-peer protocol. Does that make sense? So
Okay,
like,
but how do we communicate with small dot?
yes, like I mean, you can communicate it in a number of ways to Smoldot. Sure, like it happens to be JSON RPC. But sure, okay. So the light client, the light client, most definitely must have a JSON RPC, so that it can be useful for sure. But a full node, does a full node not need to have a JSON RPC? It's not a right-wrong answer. I just want you guys to think: is it required?
So I think it should have, but it's not required, because if you don't use it for the runtime API or something like that, and you don't use it, I think. So let's say we want just to track the states of the blockchain through the full node, and we don't want to expose it to people. We want to read it locally. Then why would we expose any RPC API? We don't want to expose anything. We just want to communicate through P2P with other nodes and just write the blockchain state to our PC.
So
that's why we don't have to, I think,
yeah.
But we should, if we want to communicate with blockchain through external with some, I don't know, front end or something like that.
Okay, fair enough. Anyone else wants to give a shot? Yeah.
They should expose the APIs only for something like rollup or somewhere they need data to be available.
The APIs for, pardon me again?
Full nodes can expose the APIs only for a data processing entity in the ecosystem, like rollups or something else, but not for clients.
But not for clients.
Yeah.
Interesting take. Okay. Okay, I'm going to tell you what I think. So the first thing to realize is that there are different kinds of nodes, right? Like the kind of node that she was describing. Your name again? Sorry. What, like the kind of node that she was describing is usually an archive node, because an indexer normally uses an archive node, right? Like an archive node is like one where like the state doesn't ever get pruned ever, right? Like it's humongous and you know it stays there. So for archiving purposes, you most definitely need some sort of ingest system, and it strikes to me that a RPC is needed. Now, we have these archive nodes. Then we also have full nodes, right? Like full nodes are the ones that are operating day to day. They keep the peers happy and stuff. Now, do full nodes really need to expose a JSON RPC API? They don't need to. It's not a critical part of their functionality, but it is convenient, at least for certain things, right? Like node operators, they need to debug things. They need to send messages. They need to stop it. They need to, so even if it's just not open to everyone else and you only have it open to your node operator, you may want to have some JSON RPC APIs for those, right? Yeah. Then there is another kind of nodes, which is the light client. And as someone rightfully pointed out, like, well, how else are going to applications talk with the light client? Like, are they going to also peer-to-peer? Like, doesn't make sense, right? So the right answer is that in reality, ideally, we would like to have different JSON RPCs depending on both the consumer and also the kind of node that we use. Does that make sense? Yeah? Okay, so we kind of talk about this, and then different kinds of consumers, right? So there are dApps, there are indexers, as she pointed out, there are wallets, and these different consumers, they have different needs, right? Bridges, by the way, monitoring systems, what we just discussed. Okay, so hands-on. Let's see if you wake up now. Hands-on. Oh no, we have to do hands-on now. So I'm going to discuss the legacy JSON RPC. Okay, so we're going to do something fun. Not really, but like we're going to go to Google and we're going to just search for Polkadot JSON RPC, and we all know Google is never wrong, right? So the first result in Google.
My fellows here in the back row can't see. I'm afraid.
So Google can't be wrong. So I just looked for Polkadot JSON RPC. So the first result, and also there is an AI overview that's super accurate. It isn't. That was sarcasm in case it's not clear. So if we go to this link, we have this amazing specification. It's so good. Now here we have like all these endpoints, and they're very interesting. There are so many. So let's choose one of them, and let's see how useful they are. You can see that it's a little bit all over the place, but we're going to use these. We're going to go to the chain, and we're going to subscribe to new heads, right? Like we're going to see like the headers coming in real time. Okay, so using the old legacy, this is the legacy API. So I have a script prepared here. If I uncomment this. Coolio. So I'm using some super low-level library that Papi uses internally, but I think it's understandable. So I'm creating a client. I have an enhancer here. This is like a middleware of the provider, so that I can track the logs, and then we can put them like everything that's happening over the wire. It will go into a file, and then PBA legacy .logs, and then we'll be able to review it. And then I'm going to call this function here, the one for subscribe all heads. So I have it here ready. And this is one of those ones that you see, it's very well documented in here, right? Because it says you subscribe to all heads, and then it returns a header. So how does this subscription work? Like it retrieves the newest header via subscription. The subscription is not part of the JSON RPC. Like, should tell me how am I going to listen to these things, right? But don't worry about it. I already solved it. But let's see. Like also like it talks about this header. So what? I'm just trying to point out that these docs are like really bad, and that there is like this is not a spec, and that on top of that is tightly coupled to a specific library. But basically, here it's saying that it's going to return a header. Like I'm going to be receiving headers. So since it's not well defined in here, header hash. That's a good guess. That's what I would have expected, at least. Okay, let's see what we get. Let's see what we get. So I'm going to run this. You get out. All right. Are you excited to see what we're going to receive? What is this? Oh, another one. I'm going to make it a little bit smaller, as long as you can see. Okay, so
We don't see.
I'm going to stop it now. We already got a few heads. So these are blocks. These are headers of blocks. But so do you notice something about this header? It's like, where is the block hash of the header? Oh, you find it in any of the properties? I don't see it. Does anyone find the block hash there? It's not there. Okay, no problem. So how can we calculate the block hash? Because like we get like the point of this is that to track like the forks that we're receiving, right? Like, you know, so if I get a block and then I get another block, I don't know if this next block that I got is a child of this one or a child of another one that I got before. So how do I relate them with these messages? Can someone tell me? What would you do? There is someone that wants to let us know. Well,
Wait a second, I'm coming.
Root on top of the parent hash? I don't know.
what?
Can you apply the extrinsic root on top of the parent hash?
The extrinsic root. No, like the block hash. The block hash is if all this was a scale encoded and it was binary data, the block hash is applying the hasher, which is normally like 256, to that binary data. Now the question is like, so the real answer here is like, now if you want to know the block hash, what you're going to have to do is you're going to take that payload, convert it to scale, which is what we will have gotten, apply the block hash, and then get it. In which case, why did we even get like this half as decoded stuff? Like basically this is like the header decoded, but not quite decoded. Like there are some parts that are not like the logs, the digest is not decoded. The other parts are kind of decoded. It's basically here we have the header information, but in a non-canonical way, in a way that it's an implementation detail of how it was convenient at a certain point in time to a library output. This is what it is, right? It's not a good API. It was not even a good API for that library, to be honest. But that's how that's how it happened, right? So I'm going to show you how we can actually work around this thing and get the block hash in a moment. Now, another question. Here we have the block number. The block number in hexadecimal, which means that it must be what? What do you guys think it is? Like scale encoded? Compact maybe? That's my guess, right? Like if I see a block number and it's small and it must be scale encoded, right? Like because if it's in hexadecimal, no. Well, it turns out that for some reason that number is not scale encoded. It's an hexadecimal value, but it's big endian, which doesn't make a lot of sense because we don't use big endian anyway. So it's kind of weird, right? Like it's like what I'm trying to explain here is that the output of this is it's just some sort of weird implementation detail of that was created at some point in time without any documentation on any logic, and it probably only made sense to the person that wrote it at that point in time. Anyways, we can work around these issues because we're not silly. So one thing that we can do is I have created this function that it's like, so I have this interface that it's called shitty header, because this is a shitty header. And then I have this function that basically what it does, it turns the shitty header into a scale encoded header, a proper scale encoded header, and then we can create the hash, and then we can get the hash, and then we can get on with our lives, and then we can decode it properly and stuff, right? So like my point is like, okay, like we can act, let's see it live. I think it's going to be cool, maybe. So we could do from you need to pass it the hasher because like different chains have different kinds of hashes. So it is in this case it's like 2 to 56, and then const from sorry. Okay, so now that we have this function, I can get the now known, it's okay, S header. We're going to call it just S header. Okay, and then we do from header. It's 2 T's or 1 T? My English is not that good. Carlo always makes fun of Victor of this
Yeah,
kind
for
of
the first
typos.
time in life, it's not that bad like this.
Okay, hash. So here we can extract the hash, and also let's get the number too properly. So what we're going to do is we're going to, when we console log it, we are going to do it with the hash and the number properly. And let's see if that makes a difference. Actually, one second. I'm just going to do that. So this is the raw, like the raw header is basically the properly scale encoded, right? No, because then, never mind. For now, we're going to just log this, okay? Which is the same data structure that we had before, but at least now it will come with a hash. Now, like the beauty of this is that now, as you can see, the function seems to be working correctly because if I look at the parent hash, this parent hash matches with this one. So that means that I calculated the hash correctly, and now I can actually, if we use this one, now at least we'll be able to correlate like this is a descendant of this one, and this is a descendant of that one, because otherwise that would be impossible. Okay, so anyways, that was just to illustrate like if you are a developer, and even if you are an advanced developer, and even if you are familiar with like how to encode like a header in scale, which, as you can imagine, is not the vast majority of the people. Like when you stumble with this JSON RPC spec, like you are like, what in the world am I dealing with here, right? Yeah. So I showed like I'm not like, well, yes, I am actually trying to I'm actually trying to nail it down to you that this is bad, but I want you to understand all the levels into which this is bad. So, no, it's important. It's important. So I want you to think of to come up like another. I'm going to, because otherwise it's going to take forever. I'm going to explain another reason why these kind of stateful subscriptions are really bad. Okay, especially when they are embedded into a node that it's supposed to be doing critical stuff. So there are moments, as much as we love like clients, and I do, and I promote its usage, unfortunately, there are lots of people that still rely into RPCs for dApps for lots of reasons. So we must have JSON RPC APIs exposed through normal load balancers, right? So if you know a little bit about networking, and if you know too much, and I'm not being super accurate, you don't have like just let's take to the point. Imagine that you have a gateway, right? Like a reverse proxy, right? And this reverse proxy receives a connection, a stateful connection. And now this reverse proxy has like 3 different nodes here, right? All of them quite busy. So if it receives a JSON RPC request that is a request reply, right? That doesn't have like a stateful connection, it can just go and, hey, you give me this reply. And as soon as I have this reply, I send it back. And the next time that you come, even if I have a stateful connection here, I don't need to keep this stateful connection forever because it's a request reply. So the next time that there is another request reply, maybe I send it to this one because this one is less busy and it comes back, right? Like, and so on and so forth. Like life is good. Like I don't need to keep stateful connections with everyone. And then if I need to bring more servers up or servers down, I can do so. Right? I can load balance but what happens when we have long-living subscriptions? When we have a long-lived subscription and someone wants to listen to the headers, well, normally what most people do is like, okay, I establish a stateful connection with this guy, and now this guy always is talking to this one, and you propagate it through here. Does that make sense? Now the problem is that if for some reason the load of your servers goes down, right, and you know, it turns out that now this node has like 3 active connections only, and this one has 10, and this one has 10, it's like, I would like to close this connection and pass it here. But what's the problem? This is a stateful connection. You cannot just close it, right? Because if you just close it, from the point of view of the actual connection that it's here, they won't know that you've closed it. They just will stop receiving data. There's no way for you to tell the consumer, hey, I'm done sending you data. If you want to keep receiving the chain heads, please ask again, right? This is basically what you would like to, if you want to have a stateful connection that it's resilient and that can be load balanced, you need some sort of convention at the application layer that says, hey, dude, this subscription is done. And then if you want to start a new one, start one, and then I'm going to send you here, and everyone's happy, right? Does that make sense? So the old JSON RPC has many of these ones that are not load balanced, that they're not load balance friendly, right? Like ideally, we would like to have as few of these ones, as few of these subscriptions that are stateful as possible, and the ones that are stateful, there should always be a way for the server to let us know, hey, this subscription is over. If you want to start it over, let me know. Is this clear? Do you understand why this is important? Yes? Hopefully. Okay. All right. So now that I already trashed about this endpoint, let me show you another interesting thing. Another thing that we can see here is that there are like all these like super redundant APIs. Many of them are actually tightly coupled to concrete palettes, which these are things that are part of the runtime. So why you will have a JSON RPC that is tightly coupled to something that can change any day and that is specific to the chain? Wouldn't it be better to have like a, wouldn't it be better to have an abstraction that allows you to make calls generically for any chain? You wanted to ask something? The microphone?
Where's the guy? Are you?
I guess I'm like familiar with like WebSocket connections that are subscriptions, but I've never actually done like a subscription using a JSON RPC. So like what are the differences that maybe you're trying to get at? Maybe I'm just not familiar with it.
So, sorry, I don't understand.
Because I think in your code, when you were showing us the example, like you were making a subscription through JSON RPC, right?
Yeah.
I guess your question right now is asking like why, like we should have a connection that will let us know when it stops, and that sounds a bit like WebSockets. Like what are the specifics? Like, can you explain a bit more about like what a subscription through JSON RPC looks like?
The question is why do we want to have a push-based notification?
No.
Do you want me to explain how WebSockets work?
No.
What's the question?
No, I understand. Like I was just saying, I understand subscriptions through like as like WebSockets, like as a pull-based subscription method.
A pull-based subscription?
Yeah, isn't that WebSockets?
What is a pull-based subscription?
Like, isn't push-based subscription like when you have like the function calls and then you like a. Wait.
So like there are two kind of ways to know if things have changed. One is pull and the other one is push, right? Like pull is like, you know, like you as a consumer, every now and then you go like, hey, you have something for me? No. Okay, cool. Do you have something for me now? No? Oh, okay, cool. Now you have something like, oh yes, I have all these blocks for you. Oh, okay, and then you get everything, and then you keep going. This is pulling, right? Like you can keep like asking, right? Like so. I mean, it's basically emulating push, but through pull. Doesn't seem like very smart, to be honest. But some people do that. Some people do that. So for most things, you can pull, right? Like, but for blockchain systems, what works best is push-pull, which is like, you definitely want to know as soon as possible when a block is there. And then for that block, you may want to pull information. Yeah. But you don't want to, like, you probably, I mean, block production is not something that happens at a rate that it's going to create a problem with back pressure, right? Like we're not talking about like streaming large amount of data. Like so, having a stateful connection for knowing the latest state of the chain head when you're building a dApp, it's, in my opinion, pretty relevant, right? Like because like you want to know as soon as possible when the balance of someone has changed, or some price has gone up, or some price has gone down. So for that, you need to know when certain state changes happen, and the way to know that is if there has been a change, if there has been a block that could have triggered that change, right? So for this reason, in some occasions, it's beneficial to have push-based notifications. Like in the end, when you do I didn't know that there was such thing as a pull-based subscription, but like a pull, I don't know what a pull-based subscription is, but like I suppose that what you're describing is polling, right? Like emulating a subscription by polling, which is like you have some sort of logic with some timer or something that pulls, and then whenever there are changes. But conceptually speaking, what you are doing there is like you are emulating push, right?
Yeah, I guess. I guess
It's okay. We are going to move on because like I'm not. I'm sorry. Like I like. Does everyone else understand why sometimes it's good to have push mixed with pull? Yeah. And just like do you understand why sometimes we want to like receive things as they are available, and then when we're interested in one of the things, pull from them? We want to have the mix of these two things. This is the thing that we're trying to get here. Okay. Cool. Next topic. Another thing that is interesting, for instance, here, like have get metadata, but this is a runtime call. So here, like we actually have two different ways of getting the metadata. We can call these, or we can just call the runtime API for getting the metadata. And interestingly, some nodes recently have had a bug in them where the only way that you can actually get the latest metadata is actually going through a runtime call. So this thing is superfluous, basically. But I'm going to ask you a question. Here we have get storage, right? Like so, get storage. This API, which in reality is the state get storage, JSON RPC. You pass it a key, and you optionally pass it a block hash. To me, it's like, why optionally? Whenever I make a query, I definitely want to know against which block I'm making the query, right? But okay, like it allows me to pass a key optionally. Now, my question to you is, if we don't pass the block hash, since it's not specified in here, which block hash do you think that the node is going to use with this version of the spec? The block hash of which block? The last one? Which last one? There could be like 3 last ones. There could be 3 forks. The last finalized. That makes sense because we have very fast finality in Polkadot, right? So if there has to be a default, probably the default must be the finalized one, right? That's what you will think, right? Well, surprise, surprise, it's not documented anywhere. That's what everyone thinks it does, but it doesn't. it gets the latest block. So what happens if there is a reorg and there's a fork? Well, you just pull data from some prune block that maybe is not there, right? Like, yeah. So since I don't have a lot more time, I think they're letting me know. Okay. The point I'm trying to convey here is that this is the JSON RPC API that was built at the very beginning when Polkadot was just starting. It started like as a fork of the ETH JSON RPC API, and then more things kept getting added and added and added. And then what it happened one day is that we had an unsung hero by the name Tomaka. Well, his name is Pierre Krieger. Everyone knows him by Tomaka, and he's the creator of Polkadot. He's the creator of Small which is like the most popular light client that we have. And then when he built the light client was working very well. And then it's like, okay, now I'm going to make I'm going to create like the JSON RPC so that dApps can actually talk with me. And then he was like, what am I supposed to implement here? What is this? Right? And then it turns out that many of these RPCs are, first off, they're not light client friendly for reasons that we're going to explain, but many of them is like, they're not documented anywhere. How is this supposed to work? Like, why is this using like, he started seeing all this madness that he didn't know it existed because like there was this library called Polkadot.js that was like hiding these around, and he thought like maybe it would be a good idea to create a proper spec so that we solve some of these problems, right? And this is how a new, beautiful, well-documented, but not widely used, unfortunately, JSON RPC API was created, okay? So what we're going to do now is we are going to do a summary of the problems. So the first thing is that the legacy JSON RPC is very poorly documented. It's very leaky, as we have seen. Like it exposes many implementation details, like what we saw with the header. Like the block number is like hexadecimal value, but it's not still encoded. It doesn't have the block hash. When you make a storage query and you don't pass the block hash, it uses the best one rather than the finalized one. It has really bad defaults in many ways. It's not load balancer friendly, what we explained before, right? Like for the RPCs, for the methods that create subscriptions, there is no way for the server to opt out from this subscription so that the server can have load balancer properties. It's not like client friendly. I could get into that later, but like it has some APIs that make it very, very difficult for the light client to actually comply with those JSON RPCs. It cannot be versioned. This is very important, right? Like if you find that one of the reasons why there are so many APIs is because they found the problem with one method, and it's like, what do we do now? I'll create another one that does it better, and they screw up again, and another one. So it cannot be versioned. So let's look at what are the goals for the modern JSON RPC. Okay, it should be properly spec'd out, right? Like you go there and everything is well explained. Everything should be clear, even if it's complex. But everything should be unequivocal. If you are a substrate developer, if you are a Polkadot developer, if you are familiar with scale and you're familiar with how things work, everything should make sense to you when you go there, right? It should gather like different clients and different consumers. Therefore, there should be different groups of functions. And then different nodes should be able to choose which these groups of functions they want to implement for them. For instance, a light client won't be able to implement archive functionalities because a light client cannot do that, right? It's not its main job, right? It should have a minimal surface API. We saw before that we had a lot of redundant APIs, lots of many different ways of accomplishing the same thing, but not one that is canonical or better than the other. this is almost always problematic, right? Should be load balancer friendly, as we explained before. Subscription summary terminated by the server. And I don't have time to get into details in here, but the legacy JSON RPC has some important issues with denial of service attacks. So this should, a goal should be the denial of service attack resilience. Okay, so why don't we go and we have a look at the beautiful JSON RPC API and we'll have a quick look at it, okay? So first off, when you go here, it's under parity for some reason that I don't understand, but
Zoom, please. Zoom in, please.
Now is my colleague that cannot see. So do not blame me.
But the point is that at least it's not tightly coupled to a particular library. So for the record, like Polkadot API, the library that myself, Victor, and Carlo are building, uses exclusively the new JSON RPC API. But there's a little, like, use exclusively the JSON RPC, the new one. And we're trying to promote it so that more teams subscribe to it so that we can start deprecating the old one, because that will allow us to have actually a lot more performant RPC gateways and anyways, and a more interoperable tooling ecosystem, right? Like, because if some tools use the old one and the new one, it's a bit of a mess. So here we have the introduction. You have, so things that we notice, right? Like the specification. If I go and I look at call, right? Like all the parameters are very well explained. In this case, the events are very well explained. There is an overview. The errors are very well spec'd out. Everything is super detailed, right? The chain head is the most critical group of functions, the most complex as well, but it's also very well documented. So we have different groups of functions. We have archive for archive nodes, like that can answer logs from anywhere. And as you can see, all the methods start with the name of the group function that they belong, their version, and the name of the method. This allows for us to create new versions as we improve. Hopefully, in the next few weeks or months, we will start proposing some improvements for chain head, because we have that in the pipeline for a while. So here we have archive and chain head are pretty much the same. The difference is that in one, you can ask for the blocks that you have seen recently, and in the other one, you can ask for the blocks of any point in time. Then we have an endpoint for chain checks. Like, this is a very critical one. Like, this is the only method that overlaps with this is the only method that overlaps with legacy, which is the one for discovering what you have available, of course. Then we have sudo for admins, transaction, and transaction watch. In my team, we are haters of transaction watch. We like transaction a lot better, but I don't have time to explain that right now. But yes, you can see it's very well documented. Okay. So one of the good things of this is that if you are a load balancer, right, you can put one node that it's an archive node for archive group of functions, and if you see that the method is an archive, you send it to that one. Then the chain head ones, you have another node that is optimized for chain head. The good thing about this is like 99% of the archive methods are request reply. There is one only, that it's diff, that for some reason they create a subscription, but that subscription, the server can opt out, right? So, yes.
This might be a dumb question.
Don't worry.
So with the metadata being automatically produced through the actual chain itself, is there a way that you could use that metadata to help define RPC functions and calls?
That's a really good question, actually. Now, just say again what you said now. Say again.
Yeah. The metadata that's automatically produced, is there a way to link that into RPC methods and functions that lets anyone call specific requests or whatever?
What do you think?
I would like that, yeah. Hopefully.
I wouldn't.
You wouldn't?
No.
Why is that?
Separation of concerns. The metadata is supposed to describe the WASM, is supposed to describe the runtime, is supposed to describe what is in the state transition function, right? The JSON RPC is a concern of the node, of some nodes, right? Like, and this is the other thing, right? Like some nodes are going to choose some group of functions and some nodes are going to improve. So by not coupling to the runtime, that gives us a lot more flexibility. So what you're saying is the opposite of what we had before. What we had before, it was a similar problem, but the other way around. So we had, like, as you see, like in the new spec, there is not a single method that is tightly coupled to a specific runtime. There's not a specific, like, there's nothing that is palette specific, right? Like, you can make any storage call that you want, but like, you just pass the storage key. You wanna make a runtime API? Sure. For which palette and which method? That's fine. But like, the spec, the endpoints, the methods, they don't know anything about the runtime. And the fact that they stay separated is a really good thing. It is a really good thing because this decoupling is what allows us to, when we realize like, oh my gosh, we need to improve this, we can improve it here without affecting the WASM and the other way around. Does that make sense? Yeah. So the real reason is separation of concerns, but it's very tempting. Now, that being said, I do agree with you that there should be a means for introspecting with the available options. So the closest that we have is RPC methods. So RPC methods only gives you the list of methods, right? And it assumes that you're familiar with how each one of these ones work. I do think that it wouldn't be that bad to enhance this a little bit more and give a little bit more of introspectability so that we can not only have the RPC method, but some metadata about how this method is supposed to work. Because for development tools, this could be very useful, actually. So I agree with that. I just wanted to make it very clear that this separation of, like, keeping the two decoupled from each other is actually a good thing. Does that make sense?
Yeah, it does. Yeah, thanks.
There's another question there.
I'm trying to look up on GitHub where the code is for this, and I'm getting confused because I see there's like two RPC implementations. One was deprecated, I think, and then the other is RPSEE. It's on the parody GitHub. It's the repo for it is JSON RPSEE.
But you're referring to libraries that consume this API.
Okay, so this is just an interface, right? This is just a spec.
This is a spec. Like,
right.
Like anyone can write like a library to use this.
I see. Okay.
So like, okay, yeah, okay, go ahead.
No, I was just trying to understand like where could I see an implementation of this, and then I saw that there was, I think, 2 repos. So I was just confused. Like, where is this actually like?
Where is implemented? Right?
Yes. Yeah.
Okay. So, Papi has like, that's how we choose to do it. Other libraries do it differently. How are we on time? No, actually, this is important. I don't care how we're in time. Like, it's more important than the stuff that we were going to look at. Okay, so check this out. This is I don't know if this is related with what you were asking, but it made me think of that, and I think it's kind of relevant. So check this out. You see this? This is the provider interface, the JSON provider interface of Podcast.js, right? So in this interface, what do we notice? Can you? No, you cannot read.
Yeah, maybe
Carlo, why didn't you let me know at the Zoom?
Scale up.
I don't want to be boring. And I also want to leave space to other students to yell at you.
Okay. So what can you notice here, right? Like this is so okay. A little bit of background. When I started working in this ecosystem in 2021, I went to this thing that was called Substrate Connect. Basically, we were creating like the tooling necessary for the light client to work with Polkadot.js at the time because other libraries didn't exist. So Polkadot.js had like this provider interface that was mostly thought for WebSocket connections. So we had to create a provider interface for Substrate Connect or for Small.dot, right? And I was like, this is insane. Like, what? Like, if you look at this interface, it has like, it leaks all these implementation details, like has subscription, it's clonable, it's connected, stats, TTL, clone, like, and many of these things, they don't really apply to small. And I was, and I was like, it would, like, sometimes people don't realize that less is more. So I don't want to brag, but like, this is the interface that we use in Puppy. That's it. That's it. This is our JSON RPC provider. You give me a callback. You give me a callback that I'm going to use to respond to you to messages or to send you notifications or to send you things. And what I respond to you is a method to send, so you can send me stuff, and a method to disconnect, right? And you may be wondering, but hold on a second, like, what about if it's connected or if it's not connected? Like, that stuff should be there, right? Should it? Well, the thing is that the good thing about this is that it allows for us to create as many middlewares as we need. So if we need to enhance it and we need to put an extra method there just for the WebSocket connection, so you can switch to another one, we can do that. Even more, it allows us to even hide anything that has to do with the protocol level, with the protocol connection. Let me show you an example. So this also has a lot to do with like separation of concerns, or like sometimes the minimal API is way more superior. So because the way that
Bless you.
So one of the things that was very difficult for us to deal with is that the light client, which is a possible connection, it's never connected or disconnected. Sometimes it's connected to 5 peers, sometimes it's connected to 0, sometimes it's connected to 6, but the communication keeps flowing with the light client. Does that make sense? Like we have, like even if we have a subscription, the light client handles all the shenanigans so that we have an active connection. And when it has more peers and it has received the data, we get it as we go, right? So like when you're talking with certain nodes, there is no such thing as like, is it connected? It's like, so we don't need to embed that into the connection. And so in our case, in fact, like when with Puppy, you may not have noticed that, but with our libraries, as soon as you create a provider, you can start sending messages. You can start making requests. You can start right away. So what do we do, even if we're not connected to the WebSocket connection? Well, we buffer it. We buffer it, and we create a proxy that buffers it. How? We enhance it, right? So because of this middleware system, we can do some really cool stuff. For instance, this code is using Puppy. This is the WebSocket provider of Puppy, right? So the WebSocket provider of Puppy, I'm not trying to brag about Puppy. This is something that it's only possible thanks to the new JSON RPC spec. But this is really cool. If you're sleeping, now is the time to wake up. You see, when we pass the WebSocket provider, we give it like 3 different endpoints, but we could give 10 or 15 or 1. It doesn't matter. This is the WebSocket provider, right? So this WebSocket provider, what does it return? The interface is this WS WebSocket provider thingy which is the exact same thing that we saw before. It's the exact same thing that we saw before. But with a few extras for a status change and whatnot. Oh, why don't I have it here? Okay, so you see, this is the JSON RPC provider, like the normal one, the ones that I showed before. But it's a superset of it, so that it has some extra properties for switching the connection or for getting to know the status, whether we're connected or disconnected or whatever. Does that make sense? So it's a superset. But the nice thing of it is that it allows us to do things as cool as these ones. Like we create a client. No, not this one. So here I'm creating a WebSocket provider. Now I just created like this little middleware for keeping the logs into a file. Why is it so easy to create this middleware? Because the only thing that the middleware has to do is like, oh, I just enhance this callback function, and every time I receive something, I put in a string that goes into a file, and then I pass it down, right? And that's it. And when I disconnect, then I close the file, right? Like I close the file and I close disconnect on the original one, right? Like so we can keep enhancing the providers, right? So you can have any sort, and this, by the way, this kind of middlewares have been very useful for us because parity developers that didn't get like the initial implementation of the spec on the node right at the first go. So because they didn't get it right, we had to make some hacks to make those nodes compliant, but we didn't put those hacks into the library because that would be horrible. So we create like these little middlewares to deal with those those little shenanigans, and then once they fix the node, we remove that middleware, and and we're good. Okay. So, but check this out. Now here we're creating. Now I'm using Papi, and I'm creating a subscription to the finalized block, and I'm also watching the value of an account changing, and I'm console logging it every time it changes. Okay. So then the other thing that we're doing is every 4 seconds, we're going to switch. We're going to switch, and we're going to kill a WebSocket connection and go to the next one. And as you will see, like everything keeps working like nothing happened. Why? You'll see in a moment. Ban modern. Come on, work. Okay, so, all right, so we're receiving blocks. Now you see the connection halted, but unable to connect. But even if it's unable to connect, as soon as it connects, we didn't miss a single block. And the connection, and by the way, we have requested some storage state that it should come at some point, by the way. Did we? Or did it come already? I didn't see it. But the point that I'm trying to make is that even if the connections are being closed, everything keeps working. Why? Because when we notice, because we have these middlewares, when we see that the connection closes, we go and it's like, okay, we're going to emulate that there has been a stop event. There has been one of these events that let us know, like, hey, you need to come back again, right? So Papi never even knows itself that there has been a disconnection. So it retries again. And things keep working like nothing happened, right? So it's thanks to these middlewares that we can do. Hold on a second, I'm pretty sure. Did I? One sec. Or did I didn't subscribe? I'm pretty sure there should have been system account watch value. Yeah, so why didn't it come? So again. Halting. Well, the internet connection is not great. So, but the point is like I'm killing the connection, and as soon as it reconnects, it keeps it's able to. The heck? I'm going to look into the logs. We're going to debug this together because this is unexpected. I want to see what's going on with that.
I had one more question. Real
Yes.
quick. Just going back to the RPC methods that Watson mentioned earlier on in the RPC interface, there's RPC methods and it gives you an array of strings referring back to the methods that you can use. Are we like losing type safety with that? Like, because now we're just getting a string of methods, but we don't know what the return values for them are.
Sorry. What
Yeah,
was that?
right here. Yeah. On the RPC, the JSON RPC interface spec that we were just looking at, the docs, and then you showed me the RPC underscore methods call, right? And then it gives you back an array of strings, which are the list of methods that are available. When we get those method names, we're losing type safety. Like we don't actually know what the return values are, or
Right. So
Okay.
the thing is that, yeah, okay. I see where you're going. Like the thing is that the JSON RPC spec. That's an interesting question. So the JSON RPC spec itself doesn't come with types, among other things, because like you may decide how you like. First off, like the way that, I mean, it could come with types in the sense that it is well defined, everything that can come, but the types that what I'm trying to explain is that when you create a library for consuming a group of functions, right? Like if you create a library for chainhead or a library for archive or like whatever, right? Like you know by spec that it's supposed to return this. So you create your own type ad hoc because according to the spec. And if there is a version 2 of the spec, you update that type. Does that make sense?
yeah,
So-
I'm specifically pointing out to like the I guess the part where you were talking about introspecting metadata to receive back like what methods are available.
Mhm. Yeah.
That's
So-
kind of where we
Yeah.
lose because it's separated, right? So it's like this is separate from what the metadata will provide you about like what is
Yeah.
accessible.
Like the reason why this is useful is imagine, right? Like for us doing runtime where the types are not very relevant because it's already running, right? We go and we check like, does this provider have archive functionalities? No. Okay. So we know how to deal with that. No. So then we know which groups of functions we can call and which ones we can't. Or like, does this one have transaction, right? Like, so if it doesn't, then I won't be able to broadcast a transaction, right? Like, so I cannot let my users to submit the transaction they can create it, but they
Yeah.
can't submit.
Okay.
I'm going to throw an error if they do, right? Like that's not. So what I'm trying to say is that, yeah, like you cannot automatically generate the types from here. Also, like each language may want to create the types in their own way, right? Like
Yeah, that's fair. Okay. Yeah, I think I'm understanding.
it's like I already got like another way to put it is like I got the types for these different ones, right? I already got the types for these different ones, and I know how to deal with them and their payloads. And then that allows me that once doing runtime, I know what's available. If I have it, I know the types, right?
Yeah. Okay. Thank you.
So yes.
Can you
Probably
open the JSON RPC response? JSON RPC response. The code. Can you open that?
This?
Yeah. So what's the parent hash? In the logs.
The what?
In like RPC response we are getting below parent hash.
The parent hash, you mean?
Yeah.
Oh, good question. Okay, so the chain head V1, it's a little bit different than the rest of the JSON RPC's APIs because the chain head, it always starts with follow, okay? So the chain head, you always start with follow, and this follow is going to basically give you certain notifications, right? The first, by spec, the first message that you will receive is initialize. It's like, okay, now we're talking, okay? And initialize is going to give you a list of the latest finalized blocks that you have. After finalized, you will start receiving new blocks, right? Like you receive finalized, new blocks. Once you receive the event best block change, now you know that you have already received all the blocks that the node that you're talking with or the provider you're talking with is aware of, right? Yeah. After that, you will, once in a while, you will receive a new finalized event. It's like, okay, like now of these blocks that I changed you, like now this is the finalized, right? And it's just going to send you the hash because you're guaranteed by spec that it will always reference a block that's been previously that's been previously communicated to you, right? And then once in a while, you will receive new block events. Notice that these events don't come with the full header. If you need the header, you can go and ask it yourself. But this is what allows us to have cool depth, not only this, but we internally have knowledge of these blocks. We know the blocks that are above the finalized block and the blocks that are below. And also, very importantly, in the chain head, there is the concept of pinning and unpinning. By default, all the blocks that are given to you are pinned, are in memory. This is especially important for the live client. It's like, I'm giving you these blocks. I have these blocks in memory. You can ask any questions that you want about these blocks. You can make a runtime call. You can make a storage request. Anything you want about this block, I will be able to give it to you. But please, whenever you're done using one of these blocks, unpin it. But please, once you're done with one of these blocks, just unpin it so that I free memory, right? So that's how it's supposed to work. And then if there is a stop event, it means, oops, the subscription is done. There are no more pin blocks. You start again, initialize, blah, 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 blah. So it works in this chain head is fully stateful, and it works with this push-pull method that we were discussing before. So yeah, this allows us to keep track of things. And if you have a look at the beautiful console that we have here, you see, like all these forks and stuff that you see here, that's how we get them. Because first we got the initialized ones, and now we're getting new blocks that reference the previous one, and this allows us to just keep in memory what we need and unpin what we need. Okay, that's it. Apparently, like we covered pretty much. Like, more questions? Last question, maybe.
So, how far can we query data back using this implementation?
So, as I explained before, with the chain head, you can only query like the stuff that you are like the subscription starts. You have some finalized blocks. It's like these are the initialized ones, and then the stuff that you're seeing coming is what you can query. Because most of the times that's what you want. You want to know the present state, right? Like you want to query the present state. Now, if you need to query things from the past, you can do that if you're talking with a node that has archive functionalities, meaning that they implement the archive group of functions, right? Now, the reality is that in theory, according to the spec, so the answer is kind of depends, because some of the nodes that say that they have archive functionality, they have as archive functionality. So for instance, like to my knowledge, the IVP ones, all of them have full archive functionality. But there are others I'm not going to name because I don't want to, that they only keep like the latest 1000 or like which don't make sense. Does that answer?
Yeah, so just another question. So can I select the archive node and like use the implementation here to get any history data from their archive, but parsing through this implementation? Because if I take the data directly, I'll need to like decode it.
The problem if you go very far in time is that if very far in time, metadata 14 was not around yet, and it was not until metadata 14 that, so right now we're in metadata version 16. Since metadata version 14, the runtime was more or less self-descriptive to the metadata, so you could automatically decode almost everything except for runtime APIs, but you have all the type information in there. But if you go very far in time and you try to use PAPI at least, even if you get like the storage value, you may not be able to decode it unless you know the exact codec to decode it. Does that make sense? Because like the metadata back very, very far back was not self-descriptive.
Okay, got it.
So you may as well use an indexer, basically, because like querying things very far from the chain, like a blockchain is keeping track of the current state, not anyways. Yes, I think I have to stop talking now. All right, thank you. If you have more questions, please ask me outside.